Look at this. Check this out. Isn't this amazing? We finally have something rendering. So what you are looking at over here is Hazel. Wait, it still says 2024.1. That took a while to recompile. But here we have Hazel 2025.1, which is using the new renderer, well, the new renderer backend, I should say, which is NVRHI. And not only is all of the UI that you're seeing here, including IMGUI with multi-viewports, which just means that you can like drag off these panels and they dynamically make their own windows, and all of that stuff is rendered using that new backend. In fact, we have our own custom IMGUI renderer now instead of using the kind of included example. The actual 3D scene is now also beginning to be rendered using all of that new technology. And I'm really, really excited because it took a while to get here, even though what you're seeing right now is this red clear color and all of the meshes in the scene are simply just bounding boxes. That's actually why we're seeing anything at all. I've just got show bounding boxes on for every entity. Even though this may not look like much, believe me, it is. So what is this video? A little bit of an update, a little bit of a devlog. I don't know what you want to call it. I don't know what I'm going to call it. I just wanted to share the fact that we have kind of reached this milestone. It's the 1st of July. I wanted to have this entire thing done, I think by the end of June, if I recall correctly. So that's, yeah, going well. Hashtag software development. But I thought this would be a really good opportunity to talk a little bit about how I approach such a mammoth task, all of the fun little quirks that we discovered along the way, and also what the next steps are and when I think this will actually be done. So first and foremost, you should know that I am live streaming myself working on this in its entirety on twitch.tv/the Cherno. Those VODs are then trimmed and put onto YouTube onto my other channel called Cherno Unplugged. I'm also using AI to take a look at the transcript of the live stream and generate this summary for it, which summarizes the gist of each stream as well as points out interesting things that happened during the stream and just makes the content a little bit easier to follow because, well, there's a lot of it. I've been really enjoying streaming all of this and interacting with you guys as well, so I think that's something that I'm hopefully going to continue doing for pretty much all of the work that I do on Hazel. And secondly, if you would like to support the project, you can go to patreon.com/thecherno, sign up for the $10 tier, and you will get access to Hazel, all of its source code, all the development branches, including this Renderer 2025 branch. You can take a look at all of the code. You can actually build and use Hazel for whatever you like. And of course, you'll be helping to support the project. So thank you for that. So what exactly was this journey like? What were the issues, and why am I so excited about a bunch of bounding boxes? What's really going on here? So first and foremost, hazelengine.com has this little Milanote board button up here. If you go there, you'll see that there is a roadmap. People who watch these videos often know where I'm going with this. There's this roadmap to release, which has Renderer 2025 over here, as well as everything that we're doing to work towards a free release. Yes, that's right. The plan is to release Hazel for free. If you want more information on that, I'll link a video up there. Anyway, the first part of that kind of is this, even though basic multiplayer, I actually made a video about this recently, which I will also link up there, kind of walking you through how that works in the first place. This is kind of almost done. This is not going to take anywhere near as much time as Renderer 2025, which has been taking a while. I do still have some concerns about what we are exactly going to do with shaders primarily. There are some suggestions to use something like slang, slang, shaderlang. I don't know. I'm just going to call it slang. To basically use something like slang, and then from there we can compile to HLSL or to GLSL or to, you know, DXIL, DXBC, and SPIR-V, and whatever else we need, even to metal shading language. In fact, slang even compiles to C++ code. So it is pretty cool, but whether or not we want to go there is like, we need to evaluate that properly. If anyone has strong opinions as to why we maybe should adopt something like slang instead of just using I mean, GLSL can actually compile into DXIL and DXBC, but not exactly directly, because we basically have to first compile GLSL to SPIR-V, then from SPIR-V to HLSL using SPIR-V cross, and then to like DXIL and DXBC. So there is that intermediate step, which I don't know, maybe they're going to iron out at some point. Those of you who have no idea what I'm talking about, I apologize. I probably shouldn't spend the whole time here talking about shaders. If you want to see a video of me talking about shaders for 20 minutes, let me know in the comment section below. Anyway, the point is that there are still some kind of pipeline quirks that I guess I need to come up with opinions and direction for. So I'm still thinking about that. But other than that, we are progressing pretty well. The way that I approached this task was I first started with the UI. So the editor inside Hazel is obviously made up of two main components as far as the rendering goes. So first of all, what you are seeing over here is just a normal window. It's a window with the title, the decoration. So like the title, the Windows default look and feel, close button, all that stuff hidden. So it's an undecorated window, which has basically this swap chain, this graphics rendering context that fills it entirely. And from there, everything you see on the screen is just drawn using Vulkan, in this case, within Hazel. So this UI that you're seeing is just a library called Dear I Am GUI, which we have been using since the very beginning, and it is excellent. By the way, did I mention we finally updated to the latest version? Finally, we were like 2.5 years behind, and then I did it. So we are now on basically the latest I Am GUI version on the docking branch. So within this whole entire window that we are fully rendering ourselves from scratch, there's obviously two main components. There's the actual UI stuff that you see here, and then there's the viewport, which is Hazel's kind of viewport that is in 3D space. It's all technically in 3D space, but the point is this is just an image that is produced by Hazel's scene renderer, which we are then rendering as an IMGUI panel, basically. So it's like an IMGUI window / panel that has an image on it, and that image is taken from a frame buffer, which is the render target for Hazel's scene renderer, which renders, all the stuff in this scene into that image. And then we display it here. And then of course we overlay some other UI elements like this stuff on top of that image. So those are the two main components. We have all of the UI rendering and the actual Hazel rendered image. Now the Hazel rendered image over here, that is the only thing that you will see in the runtime. Hazel's runtime, there's literally a project called Hazel Runtime, which is basically the application that we actually ship. So if you take a look at our currently shipped games that we just made in very short game jams, all of those games are Hazel's runtime application shipped. So that actually doesn't include any IMGUI at all. It's just basically rendering what's in this viewport. But the editor has these two main kind of renderable things. The UI using IMGUI, and then Hazel's viewport, which uses Hazel's scene renderer. Now, when it comes to complexity, rendering UI is generally much easier than rendering a 3D game. And so I looked at this and I was like, okay, well, let's just start first of all with Hazelnut instead of the Hazel runtime, because Hazelnut has all of this IMGUI code that is fairly trivial to render. Like, it's not very difficult at all to render all of this UI. Now, what do I mean by not very difficult? I mean, the shader is extremely simple and it's a single render pass. It's just render this, please. That's it. There's no like different materials. There's no different shaders. It's just as simple as here is my render pass, and then I'm going to render all of this stuff. Now, it's not a single draw call, but that doesn't really matter. The point is, it's a single render pass. That's why I decided to start with that, which is why for the longest time, we just had a blank viewport, and then we were working on getting all of this UI stuff to render. Now, there were lots and lots of quirks with this, partly also because we decided to update our IMGUI version 2.5 years forward, but we managed to work through all of those. And again, I have live streams on my Cherno Unplugged channel of me working on all of this. I don't think they start quite at the very beginning, but they start pretty far back. In fact, all of the live stream VODs related to this specific Renderer 2025 project, I've put into a Renderer 2025 playlist on my Cherno Unplugged channel. So if you actually want to see the project in order, especially if you're watching this video later and I'm working on other stuff, then check out that playlist. I'll leave a link to it in the description below. Now, of course, before I started even seeing anything on the screen, I first had to work on the device manager, the swap chain, all of that kind of stuff, which Hazel already had, except it was written in pure Vulkan. And there wasn't a really easy way for it to use different rendering backends such as DirectX 11 or 12. They obviously require their own swap chain creation code and their own device creation, device management code. So I decided let's just completely rewrite the entire swap chain, and we'll try and use as much NVRHI as possible for things like handling frame buffers, textures, all of that kind of stuff. But we did still need to use Vulkan directly in some cases because NVRHI doesn't really, it's not supposed to be a replacement for things like the swap chain. There are still scenarios in which you need to actually use render API specific code. That's normal. It's just for high level concepts like, images, textures, buffers, render passes, stuff like that, pipelines. You can just use NVRHI to describe those things instead of having to use Vulkan directly. Now, the IMGUI situation and rendering all of this UI is actually where the quirks started to show themselves. Because if we have a look at the IMGUI shader, which is now written in HLSL, you can see that it's pretty simple. There are some Vulkan specific decorations, which we had to use over here. This is based off of an existing, like very simple IMGUI HLSL shader, but we did need to change some things. Namely, this situation over here with the binding. And you might look at this and be like, okay, so you have a texture, you have a separate sampler, it's in binding 128 for some reason in Vulkan, and 0 for the texture. What's going on there? Why would this not just be 0 and 1? What's happening? And furthermore, we have this whole register situation, which is something that DirectX likes to use. Basically, without getting too deep into this, one of the quirks of NVRHI that we discovered was that they actually like to impose offsets for different types of inputs, I guess, that go into shaders. So in nvrhi.h, there is a specific Vulkan binding offsets situation, which you can see describes compile time settings for HLSL to SPIRV register allocation, and this is what they are set to. So shader resource is 0, things like textures, sampler is 128, constant buffer is 256, and unordered access, like storage buffers, is 384. So these are specific binding offsets that are applied, and where are they applied, you may ask? Well, over here inside Vulkan resource bindings.cpp, which is a Vulkan specific file, obviously, inside the create binding set function, which is basically create descriptor set, binding set, descriptor set, same kind of situation. When it goes through, and people familiar with Vulkan will recognize this code, but when we go through here and we actually generate this write descriptor data, which is basically us filling this struct of write descriptor set, which we then use with a function called update descriptor sets on the device over here. A descriptor, by the way, is just simply a way to basically link a binding point with an actual resource, such as a buffer or a texture. So in other words, this is how we tell our shader which specific texture to use, for example, at binding point 0. So you can see over here, for example, for a resource type of sampler, it actually sets the binding point, the slot, to be the register offset plus the binding slot. And that goes into this function over here as the actual destination binding. So in other words, using the little table that we have over here, that means that all samplers start at a binding point of 128 and go to, I guess, 255 as the max, and then we do constant buffers, uniform buffers from 256 and etc. Now, why? Why is this the case? Well, I presume it's to provide an effective mapping between the fact that HLSL and DirectX actually differentiate what the register, what the kind of binding point is based on what type of resource you're actually using. So you can see that the sampler has a register of S0. It's not just 0, it's S0, S for sampler. Texture has T0. If it was a storage buffer, it would have U. If it was a structured buffer or constant buffer, it would have B for buffer. And then like a slot, like 3. So obviously that means that we can have two things in effectively binding point 0, but that works for DirectX because it's not 0, it's S0. And it's not 0, it's T0. They're different things, but they're not in Vulkan. Vulkan has no way of really processing that. It does not compute. And so the way that NVRHI kind of solves this, I guess, is it's like, okay, well, let's just offset all of them by like basically a reasonable number, you know, and then we'll just say that 0 to 127 is reserved for shader resources like textures, and then, you know, 128 to 255 will be for samplers, etc. Now, here's the thing. This only really applies if you write your code in HLSL like this. And this code was required for me to actually get my sampler, my separate sampler, to show up over here. Because I was trying to use a sampler for this stuff that you are looking at over here. Still looks a little bit blocky because we're not using MIPS. But basically, this was just set to nearest filtering, point filtering, super sharp, no filtering at all for any of this when I had this set to something else like 1 and I was trying to bind to 1 because we have this offset going on. And that took a little bit of time to figure out, and we did. I'll try and link the live stream on my other channel to where that happened over there. So that is a little strange. But again, I think that only happened because we are in HLSL land here. And by the way, Hazel supports both HLSL and GLSL shaders. We have shader compiler, shader reflection systems for both. We don't really treat them any differently at the end of the day. And obviously this HLSL stuff is still compiled into SPIR-V. The problem is that when we look at a GLSL shader, such as this, I could not get this uniform buffer, and this literally happened in the live stream yesterday. I could not get this uniform buffer camera to actually work. It just would not show up in RenderDoc. The numbers I was getting were just all garbage. What was going on with this? It's just a simple uniform buffer. It's in set 1 and it's in binding 0. But what was happening was because of NVRHI's weird offset table situation thing, this was actually landing in, I think, 256, because remember, that's the offset for constant buffers. So it was landing in 256 in some cases. But what would also happen is if I tried to manually set this to 256, it would also take the binding point from here via Hazel's shader reflection system and then try and add that on, and so it would be at 512, and it was just a complete mess. So what I ended up doing was just going over here and just setting it back to 0. Now of course I could have used these const expert functions as well, but I just set it to 0. And I'm assuming this is going to break things potentially for certain HLSL shaders that we might have, or anyway, I got to figure this out. This is work in progress. I'm just sharing it with you. It's part of a devlog. I don't have a solution for this that I'm like, you know, confident in. But yeah, that's where we're at right now. And then setting this back to 0 so that it would actually, you know, when it creates the right descriptor set data, it would actually set the destination binding to what it would be for something like, here it is, constant buffer. You can see it's trying to do that register offset plus binding slot, but register offset is now 0. So therefore it's really just using that binding slot. So that's definitely something we have to figure out, but obviously the uniform buffer is working. We're seeing our actual scene, which means that the camera is working, and inside that shader, the render 2D line shader that just draws colored lines, you can see it's multiplying the vertex position and everything by this uniform buffer, which is our camera. That's probably one of the biggest quirks that I've uncovered with NVRHI. The other big thing is we were leaking a lot of memory, something like 300, 400 meg per second or something like that. And that was because that was kind of my fault, but you need to make sure you do this once per frame. And that is basically run garbage collection. Because what happens is every time you open a command buffer or a command list using NVRHI, it doesn't put it back into a pool where you can reuse it unless you actually run garbage collection. So what's interesting is that the garbage collection, you'd think it would like clean up resources or do something. In Vulkan, in the Vulkan backend, all it does is retires command buffers. It will just go to retire command buffers and it will kind of have a look at, I guess, the command buffers that are done and put them like back into this command buffers pool. And that's important because when you get or create command buffer, which is a common function that happens every time you actually open a command buffer command list for writing, you can see if the pool is empty, it will keep creating new command buffers, and create command buffer will actually also create its own command pool. So lots of memory allocation happening there. Whereas if the command buffers pool is not empty because you've called run garbage collection, then it will actually go through and use one of the existing ones that have been retired via, maybe I should retire, have been retired via the run garbage collection command. So those are kind of the two main big things. Other than that, it's been pretty smooth sailing. The other thing I learned about during the live streams was there's actually another RHI, render hardware interface, render interface, that NVIDIA, you know, have on their GitHub, which is the NVIDIA render interface, NRI. And this is very interesting. I don't know, maybe I should have used this from the beginning. It's a bit lower level. It has like, it kind of supports metal through Molten VK though, so it doesn't really have like a metal backend, but it works with Molten VK, which kind of, you know, converts Vulkan to metal code. I had a very quick look at this. As far as I understand, it's a little bit more performant in the sense that it doesn't recklessly allocate memory, which I've been finding that NVRHI does. And so I may have to, I mean, it doesn't in all aspects, but I think it does more than this library. So I might have to tame NVRHI a little bit. But what I like about NVRHI and why ultimately I decided to stick with it is because it helps with some of these high level like resource tracking, barrier placement, resource usage and lifetime. Like it has some higher level systems that I think we could definitely benefit from in Hazel, and obviously makes my job a little bit easier in the sense that I don't have to be spending all of my time engineering specifically all the rendering stuff. I can get NVRHI to do a little bit more of that so that I can focus on other areas in the engine that I also have to, you know, spend time in, not just the rendering, because that's not my job, just to be in the rendering all the time. Strangely though, I think an NRI actually provides stuff like the swap chain creation code, which is a little bit higher level because it's more like application dependent, and NVRHI doesn't, because it's like, well, that's up to the application. So it's a bit interesting. There are some things here that I guess you'd expect to be higher level. You know, it even includes like an I'm GUI renderer, and then this stuff doesn't. So that's, yeah, interesting. But they both seem pretty decent. So I don't know. I guess the other change is that we now do all of this I'm GUI rendering. We actually do that all ourselves now. So what we used to do is over here inside I'm GUI, there is an examples directory inside the I'm GUI repository. And then you can see there are examples for everything. So we actually used to use the Vulkan example. Where's GLFW Vulkan? So we used to use, which actually isn't in here, I just realized, backends. Sorry, backends. Here it is, I'm GUI impl Vulkan. We used to use this file directly to do all of the Vulkan stuff. So the rendering was actually all done using I'm GUI, using their like backend example. It worked fine. I mean, it supported viewports as well, which is the multiple windows situation. It worked pretty well, and I kind of wanted to stick with it. But with this new system, it became apparent that it was a little bit difficult. Also, I didn't quite like the fact that this paired with the GLFW file, because there was a GLFW file for I'm GUI as well, an example. Together, they would like, you know, create their own swap chains for new windows. And it was like a lot of like very specific code that ran standalone kind of on its own, segregated outside of Hazel's main rendering and window management code, which I wasn't thrilled about. So all of that is now gone because we have our own code that renders I'm GUI stuff. So we have, you can see inside Hazel, we have this I'm GUI renderer over here. And that actually uses, inside the render function, it actually uses NVRHI to do all of the rendering. So we go through the actual I'm GUI draw lists, and then you can see we're actually using, I mean, some of the code is actually from Hazel's render API, some of the code is, you know, directly NVRHI, which Hazel uses, and it does all of that stuff itself, as well as inside I'm GUI layer, you can see that all of this stuff like I'm GUI renderer create window, which is for creating the new kind of window on the fly if you are using multiple viewports. That's all flowing through Hazel's code, and you can see we're actually making like, you know, Vulkan swap chain, that's Hazel's class. We're using Hazel's own swap chain classes and everything to actually create these windows on the fly now, which is really cool. And then you can see render window just uses the I'm GUI renderer that we have to render directly like to the swap chain of that specific window. And then swap buffers over here is just, you know, our Vulkan swap chain present. And that's why we have our own, you know, I'm GUI shader, which again is very straightforward. But inside the old system, it was just this. It was just the embedded SPIR-V data, or embedded SPIR-V bytecode, I guess, of those actual shaders. You can see they're actually written in text over here as a comment. We were directly just using all of this stuff. So it's cool that we're kind of flowing through Hazel a little bit more now. It's a little bit more custom. It's a little bit more in our control now, even though I did end up modifying those backend files when needed. So that's like the other, I guess, big change, you know, with how we actually render all of this stuff. But I will say it was quite the achievement when we actually got all of these like multi-viewport panels working with no issue. There was actually a moment where I had to update my GPU drivers because every time I dragged this window out, it would like flash black for a frame. And I was like, that doesn't make any sense. Why is that happening? And then I was like, oh, maybe I should update my GPU drivers. I was using like NVIDIA Studio drivers for some reason instead of like the game ready ones. So I updated to the game ready ones, and it doesn't flash anymore. Oh, and it wasn't just flashing. It would, so when I used to drag windows out, I'll try and find this maybe in a live stream, but when I used to drag windows out, it would actually crash. My computer would freeze. So it wasn't just the black flashing, it would also freeze. Like, and I have to reboot my computer. So that's how bad it was, but obviously now it works fine. So I don't know, NVIDIA dodgy drivers maybe? Okay, well anyway, that is a bit of an update on what I'm working on. Mainly, again, just wanted to share the fact that we have this now, which is awesome. And again, it does seem like this is nothing, but obviously this is just the renderer 2D, but we are actually mostly flowing through the scene renderer code anyway. It's just we're not actually rendering anything. And the fact that the render pass that does all of these 2D lines is actually capable of taking in that camera uniform buffer, it's actually mostly flowing through Hazel's code. So if we have a look, this is renderer 2D, and that specific line rendering segment is over here. You can see we're creating a Hazel pipeline specification, we're setting out the layout, we're creating a render pass, a Hazel render pass, and setting camera as an input. So that system is all working. We're validating and baking that render pass. So that system, which is the exact same system that the scene renderer uses. So for things like, well, here's like the pre-depth pass, you can see it's using the exact same system. So all of that has been wired up now behind the scenes. And then when it comes to the actual draw call, which happens inside renderer 2D end scene, for the actual line pass, you can see it's doing renderer begin render pass, render geometry, and end render pass. So all of that is actually working. And this is exactly how the 3D renderer renders the 3D scene. It's just it uses different shaders, different pipelines, different inputs, different outputs, all of that stuff. So the fundamental system is working now. We just have to make sure that all the little things are actually wired up correctly and that they work. But I spent a considerable amount of time recently, like an entire live stream, which I guess isn't that long. I was like, considerable amount of time, sounds like a week, but it was like a few hours, rewriting this descriptor set manager, which I'm probably going to rename to like render resource manager or something, because now it's not descriptor set, it's not Vulkan specific anymore, but going through, all the binding layouts and basically preparing like these binding sets, descriptor sets that can be used with certain frames, and certain render passes when it's time to actually render. So that's basically all done for all of our resource types that we support. So yeah, we're making good progress. I think this should definitely be done by the end of the month, but it is going to require a lot of testing. Please let me know if you enjoyed this kind of video. I honestly did not think I was going to make a video about this at all. I just woke up today and I was like, you know what? I'm kind of excited about this. I want to make a video. If you have any follow-up questions based on what I've shown here or about Hazel in general, you want me to talk about some stuff in a chill format like this, and also definitely let me know in the comment section below. Don't forget that you can help support Hazel and get access to it by going to patreon.com/thecherno. Link will be in the description below, and I will see you guys next time. Goodbye.